What you're looking at is no standard paper crane, but it is a breakthrough development that could one day let us reuse spacecraft, build epic superhero suits, or even harvest energy for electronics. And it all relies on the ancient art of origami. Okay, so let's start at the beginning. This is a metamaterial. No, that's not a hipster material that is obnoxiously self-referential. A metamaterial is an artificial substance engineered to exhibit properties that we haven't actually found in nature, at least so far. They're designed with repeating structures, allowing them to direct and control the flow of electromagnetic or physical waves through them. Metamaterials have incredible properties like light bending abilities or superconductivity that come from their structure, not their substance. And that means that engineering teams, like this one at the University of Washington, can make reality-bending properties emerge from something as simple as acrylic and paper. This design in particular draws from the mathematical concepts of origami. While the ancient art of paper folding has been understood and utilized in Japan since at least the 17th century, there are remarkably few studies about the dynamics of these complex shapes that can fold and unfold from a two-dimensional sheet. You might think about a Mobius strip, for example. How many sides does it have? Is it two or three-dimensional? Take that idea one or a few hundred steps further, and you'll find the principles of origami at the core of space telescopes, deep-sea robotics, drug delivery systems, and artificial muscles. In this case, these aeronautical engineers created a beautiful modular structure using shapes they call TCOs. Poetic, I know. That stands for triangulated cylindrical origami, which makes sense when you look at their shape. Unlike other metamaterials, which typically tend to harden under compression, this structure exhibits strain softening behavior. This essentially means that the engineers found a way to turn a compression wave, that is a push or heavy impact, into a tension wave, that is a pull. Let me say that again. This structure, based on the way that its planes, creases, and tension points are arranged, can literally reverse a physical force, using nothing more than everyday materials and geometry. If that isn't magic, well, I don't know what more you want from science. What you can see in this 3D model is that as the impact from the compression wave, shown in red, propagates or travels through this structure, it creates an opposite force ahead of it, the tensile wave shown in blue. This happens so quickly that the tensile wave actually opposes the impact, softening it significantly. This is pretty nuts. Imagine football helmets or airbags made of this stuff. Imagine how useful it could be in construction areas prone to natural disasters like earthquakes. Or, my personal fantasy, combine this with optical metamaterials and you have yourself an invisible suit of armor. But I digress. If we can find ways to efficiently convert kinetic, electromagnetic, or thermal energy into electrical energy, we might be able to ditch conventional batteries entirely. The conversion of one kind of kinetic energy into its opposite is actually a huge step down this road. And finally, one of the most exciting potential applications of this tech is recyclable spacecraft. Since SpaceX's Falcon 9 demonstrated that controlled re-entry, descent, and landing was in fact possible, engineers have been fascinated with the idea of reusable rockets that would make space exploration cheaper and more accessible than ever before. Build some landing legs out of this cootie catcher and the sustainable space race might just blast off faster than we can imagine. Pretty neat that an ancient craft is paving the way for incredible innovations in 21st century technology. Subscribe to this page for more updates on all the cool new tech that's blowing our minds. For now, you have homework. First, let us know in the comments below what meta invention you're most excited for. Then share this post. Then go find Seeker on TikTok, Snapchat, Instagram, YouTube, and Amazon Prime. For extra credit, tell us what you'd like us to cover next. See you next time on Seeker.